Hi, welcome to this video about finding the volume of any prism. So volume is a matter of filling an object. And so to find the volume, you are just going to figure out how much it takes to fill the bottom layer, and then how many layers you need to get to the top, and that'll be your volume. But since it doesn't always make sense to us to find it that way, we can just use a formula. So anytime you want to find the volume of a prism, you would find the area, how much space it covers on the bottom, area of the base, and then multiply that by the height. So it's the area of the base times the height. So in this spot here in your paper, you can fill in the formula for finding the volume of any prism is the area of the base times the height of the prism. Now, sometimes instead of giving it to you as the height, they tell you it's the width of the prism. So you might see it that way. But I always think about it is when I see the base in front of me, that prism is just laying on its side. And so the height or the width is the distance between the two congruent figures. So if you can imagine that, I had a prism that was made of my one hand here and the other hand here, the width or the height would be how far apart they are. So I'll show you that on these figures. So you might see the formula one of two ways. Either you'll see it here as big BH, which big B stands for the area of the base and the height of the prism, or you might see it as big BW. They're both saying the same thing. They're just calling the one dimension that we need that's not on the base, they're either calling it the height or the width. So let's try a couple of these problems. You're going to notice that in the first one, it's a triangular prism, and I've already calculated the area of the triangle. So sometimes we think the base is the bottom, the part that's the bottom of the prism. But a prism's named for its base. So since number one is a triangular prism, then that means the triangle here is the base of the prism, even though it's facing us. It's kind of like it's laying down and we're seeing its feet, and the head of the prism is over here, and it's kind of just taking a nap, essentially. So I already know the area of the triangle is 16 units squared. That's already been found for me. So to find the volume, I'm going to write the formula. Volume is the area of the base times the height, or the width. I know that the area of the base is 16 units squared because it's already found that for me. Now I just have to figure out what's the height. And I have all of these different numbers here. And probably the main misconception people have is they think that this number here is the height because they see the right angle. But that's the height of the triangle. That's the height of the base. It's not the height of the prism. The height of the prism is the distance between the two congruent figures, or the two congruent faces. So the height here is actually 14, because that's how far apart the triangles are. So when I fill in the formula, I'm going to do the area of the base times the height, so that's times 14. And then I would just put that in a calculator. So I have the volume is 224 units cubed. So for our next shape they're finding the volume of, this one looks a little different. It's a hexagonal prism. But you don't have to worry because you, in this problem, they're already telling you what the area of the hexagon is. So you don't have to really calculate that. You just need to find the volume. So the volume would be the same as any other prism. The volume is the area of the base times the height. Or maybe you might see the formula, the area of the base times the width. So it depends on the way I think of it. It might be more natural when you see this hexagon facing you, to think about the fact that how wide is this prism from hexagon to hexagon? How wide is it? So that could be, you think of that as 21. Or I can say this prism is laying on its side. I know because the hexagon is what's facing me. So the hexagon, from the hexagon in the back to this hexagon in the front, how far apart are they? That's the height. Because if I turned it up like this, then that's how tall it would be. So if you can imagine that hexagon the hexagonal prism coming off the page and lifting up towards you, so that the hexagon's in the bottom, the height would be that 21. So either way, the height or the width, whichever one you want to call it, is 21. They are telling us that the area of the hexagon, the area of the base, is 171. I'm sorry, 170.1. So I can plug that in as the big B, 170.1. These are the same, so I'm just going to go from here. And now I'm just going to calculate that. And I get 3,572.1, to be exact, meters cubed. So that's how easy it really is. I just had to multiply two numbers. Isn't that great? It's kind of like volume is so much easier than surface area. And I kind of remember it this way, like volume is only one word. So it's one step. I just multiply. Whereas surface area, it was two words. I had to find the area and add them. But volume is going to be much simpler, unless you get a shape kind of like number 3. So number 3 is what we call an irregular polygonal prism. And it kind of goes back to what we were doing before with composite shapes. But it's not that bad. I just need to figure out the shape of the base. So the base here is going to be the same. I look for the two figures that are congruent. So I know this shape is on top, and there's a matching one just like it on the bottom. And so I'm going to take this L shape and I'm going to redraw it for myself. So it's 6, and then there's a 9, and then there's a little piece here. It kind of goes up and makes this L and then comes back here. And if I'm tracing, I know this that matches this number here, 3. And this is 6, and the 9, and then this is 2. And the other ones aren't labeled for me. So I know how to find the area of this L. I'm not just going to be able to multiply two numbers together. I'm going to look at it as two rectangles. I have this rectangle up top. That is 3 by 6. And then I have this rectangle down here, which is not 9 by 2, because I've cut some of it off. So I've cut off this amount, which is 3. So that means this would have to be 6 left, right? Because 3 plus 6 is 9. That gives me that extra piece. So the area of this skinny part of the L is 6 times 2, which is 12. And the area of this top part is 6 times 3, which is 18. So that means that the area of the base is those two things added together, which is 30. That wasn't too bad. But I'm going to find the volume of the entire figure. So volume. Volume is the area of the base times the height. The area of the base times the height. And we just found that the area of that L is 30. We just now need to figure out what's the height then of this prism. So remember, the height is the distance between the two congruent faces. So there's the L on top and the L on bottom. How far apart are they? That number really looks like the height actually in this shape, because it's this 5, the 5 between the two of them. So that would be, the height is 5 inches. This is the first one that didn't look like that side number. These are actually standing up on the way we would expect it to be, up and down. So now I have all my dimensions. I have 30 for the area of the base, 5 for the height. I just need to multiply them together to find the volume. And I get 150 inches cubed. So there it is.